Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Adityas dan Wirya with student number 253120002 from Informatics class 20A. It's a pleasure to stand here today and present a topic that lies at the heart of computer technology, the function and structure of the processor. As informatics students, we often talk about software programming and network, but all of this depend on the one thing, the processor. Without a processor, a computer is just a lifeless box filled with electronic components. So today I will explain what the processor is, how it functions, how it's structured, and why it's so important in modern computing. Let's begin with a definition. The processor is also called the central processing unit atau CPU or CPU as the core component of a computer system that perform calculation, make decision, and manage all other hardware components. LH as the brain of the computer processing and data and structure at the interval speeds. When you speed an application, the CPU interprets every instruction line by line, whether it's displaying text, calculation number, or loading image. Everything that's happening inside the computer begins and with a processor. And modern system processors are not just found in the computer. They exist in smartphones, smart TV, cars, and even household applications. Every digital device and perform logical decision or calculation contains a processor inside it. This shows how the important processor not just a computer, but for almost every technology we use our daily lives. Now let's talk about the function of the processor. In general, the CPU performs four major functions: data processing, control, storage, and communication. This one, data processing function. The most fundamental role of processor is to process data. It performs arithmetic operation like addition, subtraction, multiplication, and division. It also executing logical operations such in comparison. For example, determining whether a value is greater than, less than, or equal to another. Every program we run involves this logical and mathematics process. Even simple activities like moving the cursor on the screen require thousands of calculations per second. Modern processors handle data in binary form, meaning all operations are done using 0 second and 1 second. The speed at which it performs this operation is measured in hertz, specifically gigahertz in the modern CPU. 1 gigahertz means 1 billion cycles per second, which shows how incredibly fast processing works. 2. Control function. The processor is also the control of the computer system. It sends timing and control signals that ensure all components work in harmony. For example, when a file is saved, the CPU tells the memory to send data to a hard drive. It also decides the order which instructions are executed, the managing the flow of operation inside the computer. 3. Storage function. The CPU could temporarily store data instruction inside small memory unit called register. Register hold and the data processor is currently using allowing extremely for access compared the main memory RAM. This is crucial is performed because if the CPU had to fetch every bit of data from RAM, processing would be much slower. For communication function. Finally, the CPU communicates with memory and input or output device using electric pathways. They carry data and signal. There are three main types of buses. The data bus, which transfer actual data. The address bus which tells where data is located, and the control bus which sends control signal as coordinate operation. These buses ensure all components work together on a single system. Next, let's move one structure of the processor. What's inside the CPU? That allows is a perform tools imaging text. The perform has several key components. Is one arithmetic logical unit, ALU. The ALU is responsible for carrying out arithmetic and logical operation. For example, when you run a program that calculates for exam score of converts the temperature from Celsius to Fahrenheit, the ALU from the test mathematics steps. It also handles logical compression like if greater than or if equal to conditions that are common in programming. 2. Control unit CU. The control unit acts the director of the CPU. It does not process data itself but controls how data moves between memory. The LU, with the other components, is a read instruction from the memory decoder then send the right control signals to make the things happen. This coordinate switch. You can imagine if the conductor of the etc. doesn't play an instrument but without the music would be chaos. 3. Register. Registers are tiny but very fast memory cells located inside the processor. They store data, instruction, and intermediate result temporarily. Example include the accumulator with stored immediate arithmetic result, and the program counter which keeps track of which instructions shall be executed next. 4. Cache memory. Modern processors also have built-in cache memory, small but very fast memory used to store frequently accessed data. They are usually 3 level Li1, Li2, and Li3 caches. The closer cache is the core, the faster it is. Cache help reduce delays because the processor doesn't have to fetch data from slower RAM and the time. 5. Clock and control logic. The processor also contains a clock which synchronizes operation using electric pulses. They ensure that its process happens the correct order and timing. The faster the clock, the more instruction can be executed per second. Now, how does the process actually work? The CPU follows the process canal. The instruction size which consists of all four main steps: fetch, decode, execute, and store. 1. Fetch. The CPU fetches instruction from memory. 2. Decode. The control unit interprets the instruction to determine what operation is needed. 3. Execute. The LEO or the relevant unit performs the operation, for example, a calculation or a data movement. 4. Store. The result is stored or registered or written back to memory. This cycle happens billions of times per second, which what allow modern computers to run complex software and games smoothly. Today, processors are much more advanced than the past. They often have the multiple cores, meaning they can process multiple instructions at once. A dual-core processor can handle two tasks simultaneously, while at the other or even 16-core processor can handle many tasks in parallel. Another advancement is hyper-threading, which allows one core to handle multiple threads, improving multitasking efficiency. Modern CPUs also integrate graphic processing units (GPU) second for handling visual data and AI acceleration. They both perform in machine learning tasks. Manufacturers like Intel, AMD, and Apple are constantly competing to produce faster, more efficient process. For example, Apple M-series chips combine CPU, GPU, and memory in one chip, using system-on-chip architecture, resulting in high performance with low power usage. The processor means slow loading data, routine time lagging application inflection multitasking. On the other hand, the fast processor enables smooth performance with quick response and high productive and introduces the like artificial intelligence, cloud computing and gaming processor power determines how effectively the system and can process less amount of data. Of the way process design architecture are some of the most important areas of research in computer engineering today. The summarize, the processor is the central component that brings a computer to life. It has a four major functions: processing data, controlling operations, storing temporary data, and the communication with other components. A structure, including the LE control unit register and chat, allow it to perform millions of tasks every second with incredible precision. As technology evolves, processors continue to become faster, smaller, and more intelligent, powering not just a computer but nearly a modern device. So the processor is the true brain of every digital system. Thank you for listening in my presentation about the function and structure of the processor. I hope the explanation gives you a deeper understanding of how processors work and why they are so excellent in the world of computing. Thank you for my display. Wassalamualaikum warahmatullahi wabarakatuh.